everyone, we're going to find the partial fraction decomposition. This one has an irreducible quadratic factor. It also has repeated linear factors. So I split this up to get all the possible ways to get our least common denominator if you combined it back with the common denominator. When we get started, what we're going to do is we're going to clear the fractions by multiplying by our least common denominator. So this will cancel here. If you multiply it by both sides, you're going to get x plus 4 equals, I'm going to write my a. The x is going to cancel, but we still have x times x squared plus 4. And then for the b, the x squares will cancel, and we're left with x squared plus 4. And then for the c, x plus d, these two cancel. So this looks like a parentheses. Let me write this a little better. So this is c, x plus d, and this is going to be times x squared. All right, the first thing I'm going to do is let x be 0. What happens if I let x be 0? I plug a 0 in here, and if I plug a 0 in this x, what's going to happen is these two are going to cancel, because 0 times anything is 0. So that makes it easier that we don't have to fill all that out, and I'm just going to plug my 0 in here and solve for b. So we get 0 plus 4 equals b times 0 squared plus 4. So we get 4 equals 4b, so therefore b equals 1. All right, the next ones aren't as easy. We are going to have to do a system of linear equations. So let's let x equal 1. I plug everything in. We're going to get 1 plus 4 equals a times 1 times 1 squared plus 4. And then we have b times 1 squared plus 4. Then I have plus c times 1 plus d times 1 squared. You see why 1 works nicely, because it makes it easier when you're simplifying. So we're going to get 5 equals, that 1 is just 1 times 5, so that's going to be 5a. And then we're going to also have a 5b here. And this 1 is just 1 squared. So now all we're going to get is plus c plus d. All right? Now, my b was 1, so I'm going to go ahead and rewrite this again. 5 equals 5a plus 5 times 1. Remember, b equals 1. Plus c plus d. Now, when I subtract 5 from both sides, so if I subtract 5 here, I'm going to get 0 equals 5a plus c plus d. So we're going to use this in our system of linear equations that we're going to do in a minute. Now, the next one, I'll go ahead and choose x equals -1. So let's plug that in. -1 plus 4 equals a times -1 times -1 squared plus 4. Then we have plus b times -1 squared plus 4. Then plus c times -1 plus d times -1 squared. So let's see what happens here. We have, this is 3, and this is 5 times -1, so that's -5a. Again, we have 5b here. That's just going to be 1. So we're going to have minus c plus D. And again, B is 1. So when I plug in 1, I get 3 equals negative 5A plus 5 times 1 is just 5 minus C plus D. So when I subtract 5 from both sides, whoops, I'm going to get negative 2 equals negative 5A minus C plus D. All right. Now let's let, since we have 4 variables here, let's choose one more. Let's let x equal 2. So when you plug that in, you're going to get 2 plus 4 equals A times 2 times 2 squared plus 4 plus B times 2 squared plus 4 plus C times 2 plus D, and then we have times 2 squared. So simplifying this, we get 6 equals, that's going to be 16A plus, this is 8B plus, if you distribute this 4, we're going to get 8C plus 4D. This equals 4. All right. Now, again, my B is 1, so you do that. B is 1, so that's just going to be 8. Subtract the 8, and you get negative 2. All right, now we have our system of linear equations. And I'm going to solve these equations. So the first one I'm going to use is this one. We have 5A plus C plus D equals 0. And I also have negative 5A minus C plus D equals negative 2. The reason I chose this one is that when you combine these, you're eliminating both the A and the C. So we have, when we add 2 D's, you get 2D equals negative 2. Therefore, D equals negative 1. Now, if I plug in negative 1 into this equation here, I'm going to get 5A plus C minus 1 equals 0. And I'm going to solve for C. So C actually equals 1 minus 5A. Now, I'm going to substitute my C into the last equation we got, which was a 16A. So I'm going to substitute 16A plus 8C. My C now is 1 minus 5A. And then plus 4 times negative 1, because my D now is negative 1, and that equals negative 2. So now I can solve for A. So we get 16A plus 8 minus 40A minus 4 equals negative 2. Now I'm going to combine those and add them to the negative 2. So what you're going to get is negative 24A equals negative 6. And I believe I should have had an A here. Sorry about that. Now, so we get that. So A is going to be 1/4. Divide both sides by negative 24. Now we go back to our equation we wrote. C equals 1 minus 5A. We have our A. So C equals 1 minus 5 times 1/4. So 1 minus 5/4 is equal to negative 1/4. And again, that equals your C. Now I can plug in my A, B, and C. Again, my B again was 1. And my A, B, C, my D was -1. So we have all 4 coefficients there. And let's write it out. We have x plus 4 divided by x squared times x squared plus 4 equals 1/4 divided by x, plus my b was 1 over x squared, plus -1/4 x minus 1 divided by x squared plus 4. And what books usually do is they simplify this part here a little bit by pulling out the -1/4. Just pull out the -1/4, and you can write this as x plus 4. Because -1/4 times 4 is your -1. Looks just a little bit better. X squared plus 4. And that's your final answer. And that's it. Thank you. Have a nice day. Bye-bye.